Hi, everyone. Welcome to a brand new episode of the Clear to Send podcast. We have a special episode here where we're going to talk about going past passwords for authentication on your Wi-Fi networks and for anything else, really. And so we have some special guests here. First off, I want to welcome Francois back on my co-host here to the episode. Hi, Francois. How are you?
I'm good here. It feels weird to be away from you again, but
Yeah. We
it's
just
nice.
recorded in person, and now it's like a once every 2 years kind of thing where we meet in person. And then we have Beyond Identity joining us here on this podcast. So we have Ashwin Rana. Hi, Ashwin. How are you?
I'm doing good. How are you?
Great. Thanks for joining us. And we also have Ashish Bhatia. How are you?
Hi, Roel. Nice to meet you virtually again. I've been listening to your podcast for quite a number of years, both you and Francois. So really looking forward to the conversation.
All right. Yeah. And we're interested about this conversation because it's in Wi-Fi, we always just talk about authentication with like a pre-shared key. There's not even a lot of discussion about 802.1x because of the complexity of doing 802.1x. There's not a lot of enthusiasm for doing certificates and deploying certificates across many devices. Even the clients that I run into kind of shy away from that. And so you guys have this product that really goes beyond that right beyond identity. And so we wanted to hear what you guys have to say and how we can improve security for our devices and for Wi-Fi networks.
Yeah, absolutely. And that's what we want to talk about, right? We want to discuss some of the challenges with Wi-Fi security and particularly focus on authentication and authorization because you have to, you can't talk about authentication without talking about authorization. They both go hand in hand. And so as part of this, we want to kind of address these challenges on existing Wi-Fi networks and how, beyond identity is the new way, if you will, to truly verify the identity of the user. So that's what we want to, cover as part of this podcast.
So why don't you present Beyond Identity and the company, what you guys are all about? Because I think for most of our community, not a lot of people will know what you guys do.
I'd be happy to do that. So Beyond Identity as a company was established. We came out of stealth mode in April 2020. And the goal for the company was very simple. We wanted to make sure that we provide highly secure, frictionless, and context-aware authentication and authorization solution for all the use cases. The company was founded by Jim Clark, our chairman, and Tom Jermalock, our CEO, again, to eliminate password for all aspects of our life, whether we are looking at workforce applications, consumer applications, customer applications. Today, we have roughly 170 employees in US and Europe, and we provide cloud-delivered identity and access management platform for those applications we described, whether it's a secure workforce, secure customer. The whole idea is to replace password with certificate-based authentication.
That's nice.
That's the challenge right there, right? Because we'll dive into that certificate portion. Because when I think about certificates, I get kind of scared and afraid of having to deal with root CAs. I mean, I went through this with a previous client not too long ago, and I think it took, I don't know, a whole week to just try to figure out what certs they needed, what certs I needed to deploy. And passwords are just very insecure with so many enterprises. So many of them don't even change the pre-shared key, right? They continue to use that internally for their own internal Wi-Fi network. But when employees leave, they don't change it, right? So there's still that risk that the person knows the password and they don't have to be on site. They can be nearby the Wi-Fi network. So I think that's what you guys are trying to secure, right?
Yeah, that is correct. Yeah. As Ashwin mentioned, right, today Beyond Identity is predominantly deployed with enterprises trying to eliminate password for the secure workforce specifically for accessing applications that are behind a single sign-on platform, like an Okta or Microsoft Azure AD or Ping Federate, or you name it, right? There are many single sign-on platforms that employees use to access their applications. And so we eliminate passwords there, and we ensure that we are tying the identity of the device of the user to the device that they're trying to access these applications from. So it's very critical for us to ensure that the device's security posture matches the requirements of the enterprise. So that's where we have been predominantly focused on. However, while we have been doing this, the customers have come back to us and said, hey, can we use a similar mechanism that you have to authenticate users on the network side? Right, and then this includes things like providing authentication for VPN users or providing authentication for Wi-Fi users. And I come from the wireless space. I have deployed large-scale Wi-Fi networks, and also in the last few years, I have dealt with private cellular industry as well, where we've deployed private networks for large enterprise customers. So we looked at it from that lens and realized that yes, the Wi-Fi authentication predominantly requires a little bit of an upgrade. Right. So if you look at the Wi-Fi authentication schemes today, we're relying on, like if you look at the most secure way to authenticate on Wi-Fi, if you look at that, that's 802.1x with ETLS, right? So .1x establishes the dynamic keys that you need to encrypt the over-the-air session, and then ETLS provides mutual authentication. But there are challenges with implementing this technology across the board within the workforce, right? Today's workforce is not in, they're not coming into the network. They're coming in from different locations, right? Remote employees is the norm. We are in a post-COVID world, right? So authentication, like everything else, security, like everything else, has to be looked at from a very different angle. And so that's what we're trying to solve with our solution.
So thank you, Ashish. I think you brought out all the challenges which are specific to Wi-Fi, but as Robel pointed out, apart from the Wi-Fi specific challenges in general, even for large enterprise with a huge IT staff, it's a big challenge to roll out certificate-based authentication. Primarily, you need to have a root CA. You may need one or more intermediate CA. And now you have to be able to generate, distribute, and revoke certificate for each of their users and their devices.
Yes.
So that's been the biggest challenge we hear from customers. Let's say very few enterprises who are able to do that. There is still a shared secret, if you will, or the root certificate's private key. And if that ever gets compromised, then now the attacker is able to provide a certificate to anyone who they want. So those are some of the challenges we hear from our customer for certificate-based authentication in general.
Yeah, that's correct. And, elaborating a little bit on that, if you think of certificate-based mechanisms, they've been around for, more than 20 years now. As a matter of fact, we know, at Beyond Identity, because our company, our founder and chairman, Jim Clark, founded Netscape. And as part of Netscape, it was the first internet company, right? And we had the first browser. SSL was, primarily used, as a technology behind that. And so we are very familiar with SSL. We're actually using that same technology, but we're kind of doing, we're not relying on these centralized credentials, if you will, right? And, if you look back and look at some of these attacks that have occurred, right? Some of these breaches that have occurred, there has been cases where some of these private keys have been compromised. I was just reading at one of the attacks that occurred about a couple of months ago. I think Aruba HPE was engaged there, and their private key was compromised. So this is again a company that we are familiar with in the Wi-Fi world. So it is just a matter of when and not how that these credentials get stolen.
Yeah.
That is the key to keep in mind.
I think what also when it comes to operating a network with certificates, as a I guess a network guy, we get into it when we set up the solution. So we study the PKI and we get excited about it. And once it works, we just kind of leave it alone. And then if a problem occurs like 3 years down because a certificate has expired, we don't really remember all of the details. So we're like kind of not scared, but like it takes a little while to go back into it, to kind fix whatever problems we may have. So I think that's also something that, like Roa was saying at the beginning of the recording, like something that we're not really keen on working on all the time, because it's not as straightforward as just having a password for the Wi-Fi or something simpler.
And no one wants to maintain the PKI infrastructure, right?
Exactly.
Most of the clients that I have come across that do implement the certificates, it always takes a while for them, like you said, Francois, to like, okay, let me figure out what I did 3 years ago to make this work. And so there is a pain point there where they're trying to find something easier to maintain, but they don't want to hire someone dedicated to just managing a PKI infrastructure. Even some people are trying to offload that to something in AWS where they're not wanting to maintain physical hardware to maintain those PKIs. They'll use another service. But you guys take a different approach for this because you did mention, the private key gets compromised. So why don't we dive into like how that works with Beyond Identity? Because I think we've already kind of talked about those challenges, even scaling issues with like a small team, the specialty is not there. How do we simplify this a little bit better, right? Mainstream.
One last thing I would like to mention, scalability is definitely a challenge, right, with certificates. But the other thing is deploying certificates across multiple devices. Typically, what we have seen is this certificate infrastructure works very well. If you're in a Microsoft ecosystem, that works very well for Windows devices. You can push the certificates out easily. However, when you're looking at BYOD, which is now very predominant in the Wi-Fi world, right? I mean, people are accessing these resources remotely, and they want the convenience to access resources through multiple devices like iOS or Android. Then it becomes further more challenging with some of the issues that have been brought up by iOS and Android themselves when it comes to installing the certificates on these devices. So that is also one thing to keep in mind. So yeah, go ahead, Ashwin, and if we can address.
And you're also mentioning that this is not just for Wi-Fi authentication and authorization. This also applies to other applications. So you could use this one solution for many other things, not just for authenticating Wi-Fi users.
Absolutely, yes. That's what I was referring to. Our architecture, which is what Ashwin is going to get into now, where we are talking about decentralizing credentials, right? We're replacing shared credentials, passwords, or private keys, centralized credentials. And what are we replacing it with is what Ashwin will talk about. And so that is something which is, the architecture has been defined in such a way that it can be used for web logins, for accessing apps, network logins, whether it's, whether you're trying to access VPN or Wi-Fi or private cellular, trying to authenticate on that side, or RDP. There are other things that, remote desktop logins or SSH. There is also another area which is securing your software supply chain, right? If the listeners are familiar with the SolarWinds attack that happened in 2020, that opened up a new realm of this securing the software supply chain to ensure, in this particular case, the attack actually did not come from outside the organization; it came from within the organization. So when you're a developer and you're doing your code commits, to be able to make sure that the code commit is done by the authorized user from a device that has been issued to them by the company. All of those things are kind of tied into this architecture. So
Yeah, there you go, Francois. Yeah. Make sure all your code is only being modified by you.
My code is not that sensitive. So.
Not yet.
Not yet, I guess.
All right, Ashwin, go
Yeah.
ahead.
So looking at, before we jump into the beyond identity solution, I thought would be good to summarize some of what we are hearing from our customers. It's along the same line, both Francois, you and Robel touched on. So first of all, enterprises are looking to eliminate passwords from all their application. Whatever solution we provide, of course, they're looking to make sure that it's easy for their users. So what that means is, requiring MFA, additional devices, it's a challenge because now, they have to either provide phone to everyone. Users have to take out the phone from their purse, wallet, wherever. Ideally, they want to avoid that. Customers are also looking to control the policies and allow only trusted device from trusted location gain access to their resources, whether network resource like Wi-Fi or all the other applications we talked about. We also hear loud and clear that it's what customers are looking for is not just authenticate one time, but continuous authentication, because the device security posture may change. They want us to, apart from authenticating the user just based on public-private key pair or certificate-based authentication, collect additional information about the user, the device from they are coming from, check that does that comply with the corporate policy. So check the security posture of the device. Keep all those parameters in mind before you authenticate and authorize the user for a specific resource. So this is in general what we hear.
Yeah, I think what Ashwin is trying to say with MFA, with multi-factor, especially with the device piece, is most mechanisms that are used today to provide multi-factor, like if you looked at the Microsoft Authenticator or any of these other mechanisms that are passwordless, rely on the user having an additional device, meaning they'll send you a code, you look at the code, and then you enter that code somewhere, which is fine, and it's FIDO compliant, and that's fine. But then what ends up happening is there's this thing that we are hearing from our customers. You add a layer of security, but then you're also adding friction on the user experience. That's causing issues where people are calling in complaining about, hey, how many times do I have to enter this code? It's causing things like push fatigue, right? I mean, every single time I'm making a transaction, I have to go look for my phone. Sometimes the phone is not. These things are real. This is what our customers are complaining about. So the key being that whatever new mechanism you're bringing to the table, which adds an additional layer of security, should actually make it easier for the end user to adopt it, and that's the key.
Even for the administrator, because you touched upon posturing.
Yes.
Even on the Wi-Fi network, let's say somebody's device posture is now below that threshold, whatever that threshold is. Do you then take them off the Wi-Fi network because of that posture?
Yeah, we're going to talk about something very new in the Wi-Fi world, and it is called continuous authentication. So far in the Wi-Fi world, we are aware of, okay, you've authenticated and now you're on. And then there is some, a check on your Wi-Fi controller or in the cloud that allows you to be authorized for, let's say, a day or two. And typically this is set for 36 hours or 24 hours or whatever. And then after that, we require that you authenticate back. However, what we are proposing is a mechanism where once you've authenticated and we've authorized you based on your device's security posture, we made sure that it's, Ashish who's logged in, and he's logged in using a device that is compliant to what the enterprise requires. We have to ensure that they are compliant throughout. And so there is a check that we do every few minutes and report that back to the Wi-Fi cloud. And then, if something changes, right? So, and we'll talk about what are these signals risk signals that we look for, then to take action based on this. And this is where our technology is not restricted to just Wi-Fi, right? You could be on wired, you could be on VPN, And if your posture has changed, you could be on a cellular network or a Wi-Fi, or a private cellular network, and your posture changed, to be able to enforce that the device re-authenticate based on a configurable interval is what you need. You don't want to be like forgetting about it, because what if something major happened? What if someone, disables the firewall? Now you've opened up the enterprise for, this could be many different reasons, right? I mean, you are working on some issue where you notice that the firewall is blocking a particular, port or something like that, and you opened it up just for testing, but you forgot to turn it back off. So, there are many things like this that can happen. So to be able to do that on a continuous basis is something very, very new, and we're going to do that.
So you're looking at, for instance, when someone installs an application, you look at the fact that it's secure or not, or it meets the requirements, like the corporate policies, and if it doesn't, you would kind of block the access to the network, something like that.
That's correct. Or we're going to make them reauthorize, where we may have them go through our posturing and make sure that, you match. If it's not, then we may disconnect them. Or we may implement something else. We may not completely disconnect them. The enterprise might want to, give the user a chance to fix something that is by mistake. So we can do that as well. Yes.
Okay.
Yeah.
That's interesting. And going back to your, frictionless, authentication, I can relate to that. Before COVID, I used to travel a lot, and the multi-factor authentication would drive me crazy because I wouldn't have access to my data on my phone. And then I would just log in on a website, and they will see I'm in a different country, and they would send a text to my phone, but I don't have access to my phone, so I cannot authenticate. That would drive me crazy.
Yeah, I think the enterprises want to, Francois, one thing we've noticed is they want to open up access to users. They want to make it frictionless. They want you to use it's just that, these things keep bogging them down. And our answer so far to this is, let's add another rack mounts of hardware in a data center somewhere, and then maintain that, and then do all of this posturing on the network. And that's just the wrong approach. We have to rethink. We have to reimagine, this way of thinking, this way of authorizing, putting in, tons of servers in, and then, the IT doesn't want to manage those. Then you bring in some consultant to come in, manage, this piece. So it has to be, you want to change that logic. You want to go on a device and on a user. So your corporate identity is at the top, and whatever devices you have are at the chain of that identity. Your identity is at the root, and all of your devices are tied. Your identity is tied to all your devices. So now we can probably talk about the architecture. We've spoken a lot about the challenges and stuff, but Ashwin, maybe you can address what we are doing to address this decentralized nature.
Most definitely. So we already know the challenges with centralized identity. So what we have done is we've come up with a personal certificate authority, whereby a user's identity is tied to a certificate pair, if you will, stored on a trusted device. So we actually generate this public-private key pair in trusted platform module or trusted execution environment on user's device itself. And only the public key gets registered with Beyond Identity Cloud. So the private key stays on user's device in trusted platform module. We do get questions, what's the guarantee that private key doesn't get stolen from there? First of all, the TPMs are hardware-backed security, and this is the same security which is being used by Apple's iPhone, Android phones, Mac has T2 chip, Windows laptops for last 5+ years have been shipping with this security hardware as well. So this is where we are storing this. And
so you're talking about the same way that, macOS will store your fingerprint on the fingerprint reader is the exact same way they will just store, that private key, right?
That's a really good comparison. Yes, that's exactly the way the private keys are stored. And as a result of that, the TPM themselves are tamper resistant. Even if you try to access, multiple times, it will shut down for a certain period of time. So you would not be able to access. You can't just do brute force attack to get to those key.
I think a good example is that of, a few years ago, there was a a terrorist attack in San Bernardino, and FBI was trying to get to the attacker's iPhone, and they couldn't crack through the PIN. And that's the same thing. The PIN is actually stored in the secure enclave within the device. And the FBI was not able to crack into it because, of the reasons Ashwin mentioned, because you can do the code many times, but then the TPM shuts off. And so they ended up spending millions of dollars to actually go in, and eventually, Apple wouldn't give them the backdoor, and there shouldn't be, obviously. But that is what that's how secure this TPM is. And and another thing I want to talk about this TPM is Windows 11 for the enterprises that are looking to upgrade. The requirement, the basic requirement for Windows 11 is that the device should have a TPM installed.
So it's going to get better, and you mean like device support will keep on increasing, pretty much.
That's correct. We are nowadays seeing pretty much all the devices, physical devices, have the support for this. In rare circumstance, when we do come across a device which doesn't have TPM, we are able to work with software-based security as well. Similarly, in virtual environment, there are virtual TPM available, which we are able to use. So essentially what the users see is an app running on their device. It's a beyond identity authenticator, which also acts as a personal certificate authority. Now the users themselves are not aware of the fact that they are running a personal certificate authority on their device. And Francois, as you pointed out, with this approach, when you try to log in to your web SSO application, you really do not need to have any additional device. We are able to support MFA using local PIN or fingerprint or Face ID along with certificate-based authentication. And we do support this platform authenticator on Windows, Mac, Android, iOS, and Linux. So we're covering all major platforms. So you are fully covered. In rare circumstance, if you do have a need to use phone-based authentication, because if you are trying to access some application, access application from a device where you can't install the authenticator, we have similar support as Microsoft Authenticator or Google Authenticator. So you could use roaming authenticator as well.
And so the application gets pushed to the device, the user's device, either like MDM or something, right? It gets configured per beyond identity. The user doesn't have to do anything other than, I guess it has to tie to their identity first, right? The user's account. But you are able to use the biometrics that is on the actual hardware. So if I had my laptop open and I needed to authenticate, I could use the Beyond Identity app, and then the multi-factor would be my fingerprint on the laptop or the camera.
That is correct. All those options are available: fingerprint, Face ID, PIN, based multi-factor, and primary authentication using highly secure certificate-based authentication.
Yeah, and to your point, we're completely cloud native, so we're not bringing any hardware to the table. Our services run in Amazon. And the enrollment flow is seamless to the end user. All the end user gets is an email, and I will show you as part of the demo what type of email that looks like. And they enroll in our service by essentially just downloading the application and registering this credential. When they register the credential, that's where the public-private key pair gets generated. The private key stays in the device, and the public key is wrapped in a certificate and sent to our cloud. And this is the approach where no part of the private key is actually part of our cloud. It's all within the user's device. So,
and the benefit of this approach is from the end user's perspective, it's frictionless. They do not need to bring out any additional device. It's the same device from where they are trying to log in. That's all they need. And from the IT's perspective, from security's perspective, because we have platform authenticator running on the device, we are able to collect the device security posture and use that along with, of course, the authentication information, further authorize the user. So it's a benefit you see with this approach? You may have seen many passwordless solutions out there, but we're not come across, I would say, almost anyone who is using this specific approach. So that's a huge differentiator.
Yeah. And the other piece being, the authorization, right, Ashwin, like to be able to authorize the user based on the device's security posture, and what does, if you can, like, maybe you should touch on, what those risk signals are for maybe say Windows device and things like that. So
most definitely. So to begin with, first of all, we are able to do that risk posture check at registration time and every authentication time. And as Ashish pointed out, even if you are not actively trying to authenticate, at a configured interval, we are also continuously authenticating those risk signals. Some of the risk signals we check, if you have a requirement that a device has to be managed by the corporation, then we can look for, is this managed by Intune or Jamf, AirWatch, Mobile Iron, many other leading MDM vendors. We also have proven integration with endpoint security software like CrowdStrike and others. And all the integration we are talking about is not just trusting the device, but we are actually going to the cloud of those additional enterprise security provider, whether it's an MDM or endpoint security, and confirm that yes, this device is enrolled for this specific enterprise. We are also able to check natively if the firewall is on or a hard disk is encrypted or not. And based on that, make necessary decision. In case of mobile, we check for whether it's a jailbroken or rooted. We can also check if the device is domain joined or not. So enterprises get many different tools they can use to enforce a security policy. Very easy to do that as well.
And Ashwin just mentioned like a few. There are many, because we have the native app sitting on the device itself. We can check for processes, in the running, there's a registry key entry, whether the antivirus is on. And this part is very important, right? I mean, our integration with endpoint security software is very tight. One of the more common one is CrowdStrike, and they calculate, their own zero trust score, right? So we're being good partners, right? We don't want to go and we want to work with the enterprise, with the vendors that they're already working with. We don't want to go and take their business, right? So CrowdStrike, very good endpoint security software, mostly deployed in a lot of enterprises. We have a tighter integration with them where we do an API query to their cloud, and they calculate a zero trust score for the device based on what things that they are looking at real time. And we can say that, if that trust score is below a certain threshold value, that this is not compliant. So we're kind of this umbrella software sitting sitting on top of these endpoints security software like CrowdStrike, or for instance, like even Zscaler or Netscope. That's on the web proxy side. We can look for the presence of these apps and say, yes, this device actually has, is complying, is really security compliant to kind of access these resources. So they get fairly tight.
Yeah, that's really interesting. So you are applying some sort of, we don't really talk about this on the podcast, but you guys are implementing some sort of zero trust layer here.
Exactly. As a matter of fact,
okay.
As a matter of fact, what we are talking about is, bringing zero trust to Wi-Fi, if you think of it.
Yeah, I think that's the interesting part, because usually it is just a password or just a plain certificate, and then we let you on the network, right? And so you're going a little bit further with this, and then you say, all right, you've met all these requirements. Now we'll let you onto the Wi-Fi network.
Exactly.
But how do you tie that to the Wi-Fi network, right? Like what does that architecture look like? Is it just a simple, all right, where I plug in my Radius server, I'm now pointing it to the IP for beyond identity? Is that how it works?
Yeah. So today we are very deeply integrated with the Juniper Mist solution, and the reason is that what I found is that the Mist solution is actually the architecture is very, very forward thinking and modern. The Mist cloud supports a direct SAML integration to a third party IDP, and we are in essence an identity provider. So they also support, this whole concept of doing the first factor using .1x and then use a third-party IDP to verify that the user is who they say they are using SAML. So we actually directly integrate into the Mist cloud using SAML. And they have a setting on their cloud which allows for you to configure the SSO with IDP. And that's how we are able to integrate. Now, I think Aruba and Cisco and other vendors, at least I haven't, based on the research that I did, wasn't able to find these type of settings directly onto that controller. But maybe they support that on their NAC side, meaning, for instance, Cisco might have something where they are able to authenticate using a third party. I mean, they're themselves an identity provider at that point, right? So they might allow federating the identity to a third party identity using the same mechanism, but then you're expecting the enterprise to support ICE or Aruba ClearPass, or if you have a Forescout in the background. So
yeah, which you're then bringing additional hardware on site, but you're
exactly
trying to skip that. So does that mean you provision user accounts on your service? Is that where the user accounts live?
Yeah, that's a very good question, Arul. So as part of the enrollment, we have your identity. We typically get your accounts, we tie into the enterprise's directory. So typically your enterprise, any enterprise stores the user accounts in like an Active Directory, or if they are an Okta customer, then they may use Okta's universal directory, or if they're an Azure customer, that Azure supports their own directory. So each of the single sign-on engines that the enterprise uses has their own directory. Communication between directory to directory is using a standard called SCIM, and that allows for these directories to exchange user information along with additional attributes associated with the user. So we are able to synchronize with those directories using SCIM, which is again a more modern way to kind of synchronize these identities. And that allows for the CRUD operation where you can do create, update, delete type of operation. So if someone is deleting Roel's identity in Azure, that gets synchronized over to us, and then your identity is deleted there. So as soon as you're synchronized, those users who are enrolled in our service will get an email from us saying that, hey, your organization is, enrolled you in Beyond Identity service. And so now we have your identity. So when you try to authenticate on Wi-Fi, then, for instance, if you're authenticating on Mist, then Mist doesn't know anything about you. They say, hey, I don't handle this identity. Beyond Identity, here's a SAML request to you. They're delegating that to us. Once we've done our part, where we've made sure that you're in possession of that private key using TLS 1.3, right? Because we run that TLS operation between our cloud and our authenticator. We make sure that this device is in possession of the private key, and then we can do multi-factor using biometric. Once we've done our part, all we do is send a SAML assertion back to Mist saying, hey, we've verified Ashwin is who he says he is, and he's trying to access Wi-Fi, allow him in. So that is how the whole operation completes. That's the flow.
That's interesting. It's sorry, I was going to say it's interesting to see how the landscape is kind of changing with the new cloud services. So we have Mist, obviously they have a cloud architecture. You guys have a cloud architecture. We could think of I know a lot of people use Google, the Google as this identity provider, the G Suite stuff. So you can see how nowadays we could use like kind of APIs and a synchronization mechanism to kind of interconnect everyone. Ashwin, I'll let you continue. And I had one question related to delays and how long it takes for the actual authentication to take place, because thinking about all of this, we can maybe think that it's going to take a long time for everything to go through.
Yeah. So just to circle back, Raul, you had mentioned earlier that in today's world, when an employee leaves, if they know that pre-shared key or secret, then they're still able to connect to the Wi-Fi world. In this new architecture, Ashish talked about using SCIM, we would come to know that that user is no longer active. They are suspended. So let's say someone's last day was Friday at 5 p.m. At 5:01, we probably would have that event using SCIM. And so now in our cloud, that user would be suspended. And as a result of that, even though they have a trusted device which has a private key, so they're able to prove the position of private key, we would still not allow them to move forward, and they would not be able to connect to that Wi-Fi network. So it's as quick and as secure in this new world as you can imagine.
Yeah, you want to tie into the existing workforce architecture, right? So when an employee leaves, typically, HR updates on Bamboo HR or something like that. Those systems are tied into your directory, and then your directory is tied into us. So very, very good point, Ashwin. Like as soon as they leave, they're not allowed to reconnect back to Wi-Fi. And we've also solved one critical thing that I forgot to mention, Roel, in this, because there's so much that we're talking about, is BYOD. Right? The traditional way enterprises have solved BYOD is like, okay, there is a need. Employees have come back and said, we'd like to access this. I'll be more productive if I use my phone, if I'm at a ball game somewhere, and if you want me to work on something that I need to access, and I want to be able to access it right away, and I'm in possession of my phone and I'm not in possession of my laptop, I want to be able to do it, securely. So those type of use cases are coming out, right? So enterprises want to do BYOD, but there is a scare that, what if this device, they try to do something wrong or whatnot, right? With us, BYOD is simple as moving the credentials over with a click of a button into your own device, because the thinking is different, right? We are tying the identity to the device. It doesn't matter whether that device has been issued by the corporation or not. We're checking whether the device is compliant or not, and then allowing you. So you don't need to have multiple SSIDs, one for your Windows devices, one for your Android and iOS devices. Windows device, I'm going to do certificate based, but Android and iOS, I'm going to make them go through some, redirect portal, then let them enter a username, password, then, put them in a separate quarantine VLAN, then do COA. I mean, all that mentality, all that band-aid after band-aid that we've done goes away, because this is a much cleaner architecture. You have a corporate SSID, and the corporate SSID is meant for a corporate identity. And the corporate identity may have multiple devices. They all get across the board the uniform way to authenticate and authorize on Wi-Fi.
So why don't we take a look at it?
Yes, I think it's about time. I think, so let me just give me 1 second. So I'm going to do two separate flows for you.
Yeah, let me update people who are also listening to the podcast. So this is the part where we're actually going to show a visual. And so if you want to see this in action, you could head over to the show notes and we'll have a link to a YouTube video. But Ashish will actually show us what that looks like connecting to the Wi-Fi network.
Yeah, so at this point, I'm going to do two separate flows for you. I want to do a flow with OWE, which is, with the latest version of Wi-Fi. OWE is open or over-the-air wireless encryption. So far, as we are aware in the Wi-Fi world, open networks did not support over-the-air encryption. But now with OWE, it gives the user, the devices that are trying to communicate over Wi-Fi, the capability to establish a shared secret using Diffie-Hellman exchange. And then before they've even identified themselves to each other. So before mutual authentication takes place, you do OWE and establish a shared secret, encrypt that channel, and now exchange your authentication information. So I'm going to do the first flow with OWE on an Android, Samsung, my old company. I want to promote my old company. The Samsung Note 20 supports OWE, so that's what I'm going to be using, and I'm connecting to a MIST Wi-Fi solution, MIST AP12. So what I'm showing right now is the enrollment email that an employee would receive when they are enrolled into the Beyond Identity service. So in this particular case, they get the email, and they are asked to implement two steps. First step is to download the Authenticator app on whatever device they are in, whether they are using Android or Mac OS or Windows or Linux or whatever other machine they have, which supports all of these major OSs. They'll get this email, they'll download the app. Step number 2 is to register the credentials. This is where, when Ashwin was talking about that once you've downloaded the app, then we need to make sure that we generate a private public key pair. And so when you register the credential, a private key is generated and it's stored in the secure enclave of this device, which is similar to a trusted platform module, which is a hardware insulated from the rest of the network. And then the public key is wrapped in a certificate and it's sent to our cloud. So that's how the pair is generated. So the private key is in the device, and the public key is with us, and then your identity is the root of that certificate. So once you do that, then you essentially see a Beyond Identity app on your device. So you click on that, and you'll see
this
that
one is the Authenticator app that you had in the email, right?
That's correct. This is the app that I downloaded. So I already downloaded, I already registered the credential. And so you can see that right now I have one credential on this device, and it's tied to my tenant on the cloud. So this one says Wi-Fi demo, but in reality, it would be XYZ Corp, right? And so when I'm looking at the Authenticator app, I can right away see that I have the capability to set up other devices. So if I click on that, this is where BYOD would come into play. So when you set up other devices, we're going to ensure that you are who you are, and then you can go ahead and copy the QR code and go from there. Oh, sorry, unfortunately I'm not connected to Wi-Fi yet, so that functionality is not. I'm going to come back to it once I have network connectivity.
I do have one question about this part here. Is only one device capable of setting up other devices, or once you set up another device, and that device can also set up other devices?
Yeah, so that's a very good question, and I'll answer it. So there's no cascading, right? So this is your primary device for now, and from here you can set up other devices. So I can move this credential over to a Windows device, and then from Windows I can move the credential over to my Mac device, right? So, but if I invalidate the credentials on this device, that would also invalidate. Ashwin, correct me if I'm wrong. That would also invalidate the credential. No, it would not. Sorry. So I'm mistaken. Maybe Ashwin, you can clarify that.
Sorry about that. Yeah. So it would not invalidate as such. Once the device is enrolled, it's self-sufficient. You could add any additional device from that device. And even if the main device from where you transferred for some reason is lost or stolen, or you're no longer using that, you could revoke that without any problems.
There you go. So thanks for clarifying that. So if this device is stolen, we can delete the device from the admin console. We can invalidate the credentials on this device, but the other devices still stay. So this is how it is. And by the way, the setup devices didn't work because I don't have Wi-Fi connectivity yet. So at this point, what I'm going to do is I'm going to connect to Beyond Identity. And the reason I'm showing OWE is, remember, we were talking about security, and we have to ensure that we address both the encryption, over-the-air encryption, as well as the authentication. So I don't want to do open wireless network. I don't want to promote open wireless networks, because our stuff comes at layer 3. So we want to make sure that your over-the-air session is also encrypted. So I'm going to go ahead and connect to Beyond Identity. Right now I am saying connecting. And at this point, I would be asked to sign into the Wi-Fi network, which is what I'm going to click. As soon as I click that, it is trying to locate the platform authenticator or the app. At this point, the app is invoked, and then it is doing. So you can see the Beyond Identity is trying to enforce your organization security policy. So I did a face recognition, I confirm, and that is done. And as soon as that is done, I'm connected to Wi-Fi. So it was as simple as validating your private key and doing the Wi-Fi connection making sure the biometrics, very, very, very little or minimal friction for the user.
Does the user only have to do that one time once they associate to that SSID, or are they going to see that multiple times? Like they go home for the day, come back tomorrow, are they going to have to use
It
that?
all depends on how long you are authorizing the device. So in Mist, I have authorized this for 24 hours. So let's say they come back in 24 hours, they'll have to do it again. Or a continuous authentication event occurs, right? So now the app is running on the device, right? And now the continuous authentication begins. We are every few configurable minutes sending something back to the cloud saying, hey, right now the posture is okay, but something changed on the device, right? Let's look at an example. What Ashwin was talking about, let me just stop share here. This is a very good point, right? And let's look at a scenario where the organization wants to ensure that you only log into Wi-Fi from certain location-based access, trusted location. And so the user went in and he connected to Wi-Fi. And then what if it goes and turns off the GPS, right? So now we don't have location information. So the next continuous auth event should detect that. And so we detect that the user has, hey, disconnected the GPS. And so now I'm going to initiate a reauthorization event, and I should be able to stop this. That device's posture has now changed. He's not complying to what I am asking them to comply to.
So when they try to join to Wi-Fi, it just denies them. It won't let them.
Yes, you'll reauthorize when you rejoin to Wi-Fi, it'll deny it. So the authorization will kick in.
How about for roaming? So if I'm walking around the office, will I have to go through that MFA again? Like what if I was on a call walking around through the office? Do any of those prompts come up?
They don't come up for roaming. We are agnostic to that process. We kick in after all of that. That happens at layer 2 or at layer 3. And so only if once you've authenticated and authorized, a reauthorization event would occur at a configurable interval. Let's say on the Mist cloud, you've set it up for, let's say, 24 hours. That would be the time, or a change in your device's security posture would trigger a reauthorization event.
So what do you see your customer? What do you see your customer using as a duration for that authentication, especially for the enterprise space where today, if you have like, let's say .1x with certificate, you don't have, the users don't go through that every week or every day. What do you see your customer using in terms of, reauthentication threshold in the enterprise space? Is it like once a week or once a day?
I think 36 hours is what I've seen for the most part. But this is where the conversations around continuous authentication actually began. We want to be able, in that interval, if something changed, how do we know? And so we've kind of introduced this element to the table. So this is the example that I did was a simple OWE based connection, and I want to do what I believe is the ideal way to authenticate on Wi-Fi, right? So let's look at a Windows domain joined machine, typical use case for a enterprise. So let me just RDP into this machine. Okay, so I'm going to go ahead and connect to this SSID, which I'm calling .1x plus beyond identity. So you will see on the left side the radius messaging, and then the beyond identity authentication factor kick in. So I'm going to go ahead and connect. And you can see the radius messaging occurred very quickly, and beyond identities authentication engine was invoked, and we are connected to Wi-Fi. And so if you look, I can go to cnn.com. So I have Wi-Fi connectivity, and here is the radius messaging.
So after you made the .1x authentication, a browser page just opened, and then it connected to the Beyond Identity Cloud to do that second layer, I guess, of authentication. Exactly. And on your computer, you already have the Authenticator application installed, right?
Exactly. Okay. There is an Beyond Identity Authenticator app, which it looks very similar. Look and feel is very similar. This is the platform authenticator, and you can see the same Wi-Fi demo, and you can see set up other devices, right, that I can use. And, that's how, we are able to transfer the credentials. In this particular case, Windows devices support a trusted platform module. And so we're storing the private key in this particular case in a TPM of the device.
Okay.
So this is how the flow works with Windows. Now I think let me go ahead and show you what I've done on Mist. It might be a good way to segue into the Mist configuration.
Yeah, I'd be interested in seeing what that looks like and seeing if that's something people can do easily.
So let's look at .1x plus beyond identity, because that's the interesting one, right? So you would go about configuring your security as WPA2 E.1x. You can also do WPA3 E1x .1x. And then once you've done that, you are going to configure your radius authentication. Mist also supports secure radius, so I would recommend that you enable that and ensure that your radius transaction on the other side is also secure, so you don't share those keys that are exchanged as part of the radius. And then once that is done, you will come to what is called as the guest portal. And there is something which is called as SSO with identity provider. In this particular case, Mist is going to be connecting with Beyond Identities Cloud. So Mist Cloud is going to talk to Beyond Identities Cloud using the SAML protocol. And you can see the configuration parameters for SAML. We typically give the issuer and the SSO URL. This is where the redirects occur. And that browser page opened up and it went through and looked for our platform authenticator on the device itself. So this is how we have configured the Mist platform.
And all of these SAML settings are provided by Beyond Identity?
Yes, so it's both ways. The Beyond Identity is the issuer, the Beyond Identity certificate and the SSO URL comes from us.
Okay.
And then we, in turn, configure the portal SSO URL that Mist provides on our end. So
you have to do a little bit of Beyond Identity configuration on the Mist Cloud, and you have to do a little bit of Mist Cloud configuration on the Beyond Identity Cloud.
Exactly, that's right. And then the Beyond Identity Cloud already has the directory of, or is already synchronized with the directory of the organization to get the user's information. So, Mist is not maintaining that user directory.
Do you guys have all of that documented? How you integrate with different solutions?
Yes, we have, Ashwin and I are, Ashwin's org within Beyond Identity is responsible for integration, all the technology integration. So we maintain all that documentation. I have personally written the integration guide with Mist, which we will be eventually sharing on our website.
Okay, awesome. Well, we'll share a link whenever it's public so our listeners can take a look at it as well.
Yeah, I think overall it was a pretty nice setup beyond going authentication just over Wi-Fi, right? Because now I'm doing the continuous authorization, right? The posturing. I think that's, for me, that's the a key part, because it adds additional security, especially for devices that the organization might not have control over, right? Like you talked about BYOD, people wanting to use their own devices.
Yes.
Even maybe for vendors that come on site, like you want to be able to check the posture of the vendor devices. Because we hear about people getting hacked, not necessarily the organization gets hacked, but a partner that they work with gets hacked, and they have access to a bunch of their data as well. So I think
then they can get enrolled in our service and then get onto the Wi-Fi. So at least you're making sure that those vendors that are coming in, working for, let's say, a week or so, are posture compliant. So that is, that's the key. Now the thing is, one of the interesting things, Royal, I want to bring out about continuous authentication is it's not just limited to Wi-Fi or private wireless networks. You could be in, let's say you are an employee of a company and you are enrolled in the Beyond Identity service. Now, these days, if you look at companies like Mist, Aruba, Cisco, they are actually, obviously they want the users or their IT administrators to go to their cloud as a single pane of glass to manage not just the Wi-Fi, but also the wired infrastructure, the VPN infrastructure. Let's take an example of Juniper Mist. They have the Wi-Fi side. They also have the Juniper firewalls that they want to eventually bring into the Mist cloud. They have the SD-WAN solution, all of that good stuff, right? That will eventually now come into the, I don't know what level of support they have on the Mist right now, but like, the vision would be to have this single pane of glass where the IT admin goes in and configures everything, that AI stuff that they do, right? So now look at the situation. I talk about the post-COVID world. Employees not connecting to corporate Wi-Fi. So you've connected to corporate Wi-Fi, you've gone through the, beyond identity. You're an employee that you are accessing network resources from Starbucks. So you're sitting at Starbucks, connected to Starbucks Wi-Fi, and now you are using VPN to access these resources. Now, because Beyond Identity's application is running on the device and doing continuous authentication, which is which is independent of the Wi-Fi piece, that continuous authentication is still going over an API to either a Mist cloud or a Cisco cloud or an Aruba cloud. And if something changes, a posture changes while you're on VPN on Starbucks Wi-Fi, then to be able to take action based on that is the key. Because you may not be always on Mist Wi-Fi, especially now. So that is the magic of continuous authentication. That is where the world is going.
And on the other end, I was going to say, because of all of the APIs that also are provided by the networking vendors, you guys have an application installed on the device. So you may also be able to send additional data. Like I'm thinking about, RSSI for the Wi-Fi, SNR, all of these good metrics that we're usually blind of because we only see what the AB point of view. You guys might be able to send that data through API, maybe to, Mist, and have those integrations as well on the network side, or even, thinking about authentication. Let's say something happens, something is wrong, or the authentication didn't occur properly. Maybe you could send additional logs back to Mist. So when the network operator goes back to his Mist dashboard, he has a little bit more information about the authentication, and he can provide like a better diagnosis to kind of solve the.
Very good point. As a matter of fact, that is one of the areas that we want to work with Wi-Fi vendors on. That because we have a native app and we are doing this posturing, all of this information that we are collecting on our cloud, we would work with the vendors to use these open APIs to pass that information, the security posture of the device itself, to the API cloud. So when you're looking at the client insights on, let's say, a Mist cloud, or you're looking at some data, when you click on the client, you're not just looking at the RSSI value, you're also looking at the security posture of the device. You are looking at the zero trust score of the device, and obviously we would love to work with the Wi-Fi vendors on what all information the device is able to expose to us. What is the client's point of view, right? Today, all of that is collected on the Wi-Fi side, but we can do it on the client side. And there is not much objection to it, because it's not just serving this one purpose, right? Wi-Fi authentication is, again, one part of what we are doing. We have all these different applications that we are providing the authentication and authorization for.
So if people want to learn more about your company and the architecture and your services, like where should they go? Do you guys have a website or blogs or YouTube videos that you like to share?
Yeah, so beyondidentity.com, our marketing team is continuously updating with blogs. You should also follow us on LinkedIn. That is where we are doing a lot of these webinars, podcasts. We have live coding events that we put in. There's another world of app developers now looking to provide passwordless access to users. So how they can do that using native SDKs, right? So when you develop an app, authentication is something that is the last thing that you think about. You typically look at cloud platforms like AWS Cognito or Azure AD-B2C or Google Firebase for handling the identity of your users. But then, you can, if you want to give the passwordless experience to your users, you can also look at our native SDKs. So we do quite a lot of these events online.
So if they have questions too, can they reach out to you directly, Ashish?
Yes, they should be able to reach out to me directly. I'm at, Ashish at beyondidentity.com. Very simple.
Awesome. Well, I want to thank you guys for joining us on the podcast and sharing this new way of authenticating and authorizing users, especially over the Wi-Fi network. It goes beyond the Wi-Fi network, but we wanted to specifically touch upon the Wi-Fi network. You can authenticate and authorize users for other applications as well using that authenticator app.
Yes.
But we did want to focus a little bit more on the Wi-Fi side, since most of the listeners here are Wi-Fi, but I do know a lot of you guys out there touch upon other parts of the network, or maybe you manage the whole network infrastructure, the IT infrastructure, right? So maybe you're looking for ways to strengthen your security. So head over to clear2send.net, look for Beyond Identity, and thank you guys for joining us.
Thank you very much, guys. It was nice talk to you.
Thank you, guys. Thank you.